Bill is a New York State native. Yes, with the Sierra Club Water Sentinel and the Sierra Club. He holds a PhD as a material scientist from Cornell and is a chemical engineer from the University of Detroit Mercy. He's worked in research, development, and engineering in many sectors: foods, feminine hygiene, chemicals, ceramics, glass, and optical fiber, while employed at several Fortune 500 companies. And he was named inventor on 12 patents, and he's married to Polly with 2 sons, Alexander and Nicholas. Bill?
Thank you.
Thank you.
Well, let me say first, it's a real pleasure for me to be here, give this talk today. I'd like to thank the Sierra Club Atlantic Chapter and the Cornell Law School for inviting me. The New York Water Sentinel story is one of more of citizen science activists, grassroots citizens working together. It's not about any kind of law stuff, so bear with me on that, I guess.
It's kind of evidence building.
Yeah, it is kind of evidence building, you're right.
That's a tool. That's part of our theme, is to provide tools.
That's right. So, citizen science, I guess. So, the mission of the New York Water Sentinels was to monitor the surface streams of the southern tier, mainly for the guarding of the water against the hydrofracking that was coming. We thought it was coming. You know, the Marcellus Shale. It looked probable in the near-term future. It was 2012 at the time, and so we were very concerned about the hydrofracking operations coming to town. And so we wanted to monitor the surface streams. How are we going to do that? Well, the first thing we were going to do is characterize the streams, what we called establishing a baseline of the conductivity. I'll use those 2 terms interchangeably. TDS is total dissolved solids, and conductivity is a way of measuring the total dissolved solids of these streams prior to the hydrofracking activity getting there. So we know what the conductivity or the amount of salts in the streams were before hydrofracking activity. Part of the hydrofracking process, when they put the water down into the well to frack the rock, they release the pressure after they, put something like 15,000 pounds. And then that water comes back up, and it's extremely salty. They put it into lagoons, or they used to, and if those lagoons overflow, the salt water gets into the streams and fouls the freshwater streams. So these are all freshwater streams that are not supposed to have any very much salts in them. So if some salts get into them, then that's when we're trying to report that those potential pollution events. Okay, so some organizational facts. We started in January of 2012. We've been active for about 7 years now. It's an all-volunteer group. It's affiliated with the Sierra Club, although the volunteers did not have to be a Sierra Club member. In fact, I'd say about half were not. In total, there was about 170 volunteers that came through our doors and were trained on the use of the conductivity meter and got assigned streams and all that. And also, there were 318 streams that we monitored throughout the southern tier, which included, Cattaraugus County, Allegheny. Painted Post isn't a county, but Steuben County, Chemung, Broome, Tioga, Norwich, and Delaware. Those were the actual names of the teams that we had. So you can see we were all across the whole southern tier area. So we were trained by a group in Dickinson College called ALARM, Alliance for Aquatic Resource Monitoring. And so they taught us basically the protocol to test the streams for the conductivity and stage, which is essentially depth. And so we used their protocol and trained other folks, and so we eventually got to 170 folks. Since then, we've cut back on our recruiting activities. It was a huge amount of recruiting and training involved in that. So we aren't doing that quite so much anymore. And so now we're at about 25 active members at this point. So here's some of the things that, some data that the New York Water Sentinels collect. We basically measure the total dissolved solids, that's TDS, and the stage, which is essentially what's called the depth. It's a conductivity meter, and it measures the conductivity of the stream. Of course, the more salts or the more ions that you have in the stream, the more conductive the water is. So we measure conductivity, and then the meter essentially estimates the amount of total dissolved solids from that, and it's a pretty good estimate. So what you can, we also report the weather data and things like that. We visually assess the site every time we visit a stream, and we also take a one-time water sample for barium and strontium analysis, and I'll get to why we do that in a few minutes. But you can see the form that we fill out. The green and yellow are sort of the monitor's name and the stream site location, all that kind of stuff. The blue part is the weather that we record, and then the orange table is the conductivity, total dissolved solids, and stage, which is, again, the depth. And there's a nice relationship between depth and conductivity that provides sort of the fingerprint for each of these stream sites. Okay, so what we did was establish the baseline curve for each of these 318 stream sites. And in order to establish baseline, we had to collect about 20, we had to have at least 20 TDS and stage readings, which captured the 4 seasons, you know, winter, spring, summer, fall, and captured the high and the low of the stream. So we wanted to capture the data when the stream was high, let's say in the spring, and then also low, let's say in late summer, where the stream was really low flow and low stage. Every 6 months, the volunteers went through what's called a quality assurance, quality control check. So it checks both the meter and the volunteer together, you know, so that it shows that the meter is operational and that the volunteer understands how to calibrate and use the tool. The volunteers essentially grab a sample, they take a measurement, they take that same sample and send it to a university lab. Our university labs were St. Bonaventure. It was Ted Georgian, Professor Ted Georgian in St. Bonaventure, and also Dr. Julian Shepard, a professor at Binghamton. One of those 2 labs would get the sample. The university lab would measure that same sample, and those 2 numbers, the field number from the volunteer and the university lab number, had to match by 20%. They couldn't be any more than 20% different. So, or else they would fail the QA/QC, and we'd have to fix whatever was the problem. So, but by and large, we were pretty successful because we didn't have to do that very much as far as fixing problems, although there were a few. So that was good. So for visual assessment, you know, we're just looking at things like turbidity and oil scum or foam on the surface of the water. And there was a form to fill out if you saw that kind of stuff when you made your stream visit. For the barium strontium, those are actually signature metals found in the produced water from the shale fracking operation. So, so if you found though, if there was a high salt incident, and you took a sample because the salts were high in your stream, then you could take that sample, and if it tested also high for barium and strontium, then we'd know that it was hydrofracking was the problem. Versus something like road salt, which can get into the streams and cause high salt readings in streams as well, and not be, from hydrofracking. Okay, so for the samples that were tested for barium and strontium, we used independent certified lab. Alpha Scientific was the name of them. Okay, so here's an example of a plot that captures the total dissolved solids and the relationship between total dissolved solids and the stream stage, which is the depth. So you can see that, let's say you have the stream is in the spring, it's very high because of a lot of rainwater, and you can see that, let's say it's 1.7 feet deep, and that one point off there, and you can see that the total dissolved solids are pretty low, only 100 milligrams per liter. Versus, let's say, the opposite end of the curve, where the stream's depth is very low, about 0.3 feet, and the total dissolved solids is more like 600. So just having getting a conductivity or a TDS reading of, let's say, 300, is that atypical of the stream or not? You really don't know. You have to know what the stage is as well. So, for instance, if we had a stage value, if you visited the stream and it had a stage value of, let's say, 1.7 feet, and you got a 300 reading for your TDS, that would be an atypical value. In fact, it would be 3 times higher than what you'd expect. So that would start the alarm bells going off. Hey, we've got a problem with the stream right now. In the summer, a 300 reading would be pretty typical, because we'd be more in the, let's say a half foot deep, and 300 would be typical. So that's how we use these plots to know whether our new reading was a typical reading or an atypical reading that we want to take action on. I hope everybody followed me on that. It wasn't that great. Okay, so, and here is sort of the summary of all of our activity. We have a database of data. Every stream visit, we had those 5,300 stream visits. And so you can see every one of these data points is the 318 stream sites. For each of these dots, we average the TDS over the entire year. Okay? So we average the TDS for the entire, all of the readings for that stream site, and we color-coded them. So if the TDS was between, we binned the TDS into different colored bins. The green had a TDS average of around 28 to 77, and so forth. So, so what you can see here is that first of all, we really did a fairly good job of blanketing the southern tier where all the Marcellus shale is, and got some pretty good coverage, I think. And also the color code tends to, my analysis of it, I guess, it shows that some of the areas, for instance, I guess, is there a pointer here?
There is a laser pointer on there. See the little green line?
Oh, yeah, okay. Okay, so for instance, this area here, this would be Binghamton, okay, the yellow and orange and red area. This would be Elmira area here. This is Bath. So it seems like the red areas, which are the higher areas of average TDS, are all more, urban or industrialized areas. In comparison, for instance, there's this area here, which I believe is like the national forest in Cattaraugus County. This is Allegheny and Cattaraugus, so this is, I think, national forest area. So interesting that it has those. That we can make that analysis on this data. Okay. So all the data went into our database. Our website is NewYorkWaterSentinels.org. And the volunteers get their sort of passcode. They must log in to add their data. They can only edit their own data. They can see everybody else's data, but they can only edit their own. So that's how we keep the data as secure as possible. But we have recently ported all of the data onto Alarm's database, and I'm pleased to say that we have doubled Alarm's, the size of Alarm's database. So, Alarm was focused mostly on Pennsylvania, essentially. So they had the whole state of Pennsylvania, which was, of course, actively being hydrofrac'd at the time. So they were busily training people to monitor, just the same way that they taught the New York Water Sentinels. So, and hydrofracking really never came to the New York State, but nevertheless, we had enough activity. New York really responded, and we essentially got as much data as they had for the whole state of Pennsylvania. So, hats off to the New York citizens. All right, so here's some of the new directions we're taking. So we're sort of wrapping up the TDS and stage measurements, the stream baselining effort. And now we're trying to develop sondes. We're using some funding from the Sierra Club and the Park Foundation to develop these sondes. A sonde is essentially just like a group of sensors that we put in the water. It stays there and measures all sorts of things: conductivity, temperature, pH, all every, let's say, 15 minutes or whatever. So instead of just getting a snapshot from a stream visit every once in a while, this would get essentially 24/7 look at the streams, day and night. So, and what would we use these for? Well, we wanted to maybe use these to track the outflow of wastewater treatment plants, and also to track saline discharges from the Energy Midstream LLC. That was the that was talked about. That's a Crestwood-owned facility that stores propane in salt caverns along the whoops.
No, that's not you. That's the
along the Conhockton River, and they have a Speedies permit to discharge saline into the river up to a certain point. So we want to track them and see if by putting a sonde into the water a little bit downstream and seeing how that works out. We're also looking at maybe tracking CAFO or farm runoff as part of our stream activity. So this, just so you know what a sonde looks like, this is SRBC, Susquehanna River Basin Commission's sonde in Sing Sing Creek. Sing Sing Creek is just west of Elmira, and they monitor 5 parameters. And our first try at making a sonde is really going to just take the conductivity and the temperature, and that'll be about it for now. So we're taking sort of baby steps, but we'll get more complex as time goes on, I hope. So that's what the sonde looks like. The business end is here in the water. It's basically a 4-foot PVC pipe. You can see the wires coming off the top. Those wires, this little white dot here is the head, if you can see, and this is the box where all the information goes from. The SRBC does a good job. They got like solar panels and a whole bit, so they do a great job with the Sing Sing or with their sondes. We're going to ours is going to be a little bit cheaper, I think. But,
you got about a minute.
Okay, well, I'm done.
Oh,
So
yeah.
this is a list of all the volunteers that have worked on the New York Water Sentinels to date. As you can see, it's a huge list. It's all the 175 people, something like that. So I've circled, or I've folded Jessica Helm and Arthur Kuipers. They were the founders 7 years ago. And so, but you can see the list is pretty huge. Hats off to them. Yeah, right.
Bill, I was wondering, I just had a quick question. Because the Tioga comes from Pennsylvania and actually from a heavily fracked area in Pennsylvania, was it possible to read anything on the Tioga tributaries coming up into New York State?
Well, you're right. The Tioga does come from Pennsylvania, and then forms with the Conhockton to form the Chemung, or joins with the Conhockton. We actually did track. One of our sites was on the Tioga River, but it's actually a fairly big flowing. So it would take a catastrophic event of
Big spill.
epic spill in order to show up. So they don't. The protocol asked to test only pretty small streams. So that even a small spill would be, possibly found out. Once it gets into a big river, it's so diluted that it's hard to. So we avoided directly measuring a lot of the bigger rivers and such.
Well, thank you.
Okay. Thank you.